Welcome, everybody. Thanks for gathering around the telescope with me again, so to speak, virtually. Uh, Going into the Astronomer of the Week. Last week we talked about Tycho Brahe, so it's only natural, I think, we move on to Johannes Kepler. Johannes Kepler really stands at one of those rare crossroads in history, where the old universe finally begins to give way to the modern one. He wasn't just refining astronomy, he was rewriting how the heavens worked in and of themselves, often while living in poverty, political crisis, and religious tension. Kepler's story isn't one of comfort or certainty, but of persistence, deep curiosity, and a stubborn belief that the cosmos followed discoverable rules. He also believed very deeply, I think, that individuals were connected to the cosmos. I think that was an important thing to understand about him. He actually was a man who lived through very difficult times I think very similar to what we're living in right now. He was born on December 27th, 1571 in Welderstadt in the Holy Roman Empire. Today that was near Stuttgart, Germany. His early life was anything but easy. His family struggled financially. His father disappeared during military service. He was a mercenary, and when Kepler was 5, he left. And though his parents were Protestant Lutheran, his father, as a mercenary, was hired by the Spanish army to serve in the Netherlands in the 80 Years' War, and he disappeared while he was in that service. People guessed that he was probably killed there. He had a childhood bout of smallpox that left him physically weak in his hands and visually impaired, and he felt impacted his ability to do astronomy. Yet despite these setbacks, Kepler showed an early fascination with the sky. He witnessed the Great Comet of 1577. His mother took him up on a hill so he could actually see it. And then he saw a lunar eclipse. He was asked to go outside. Describes it as being red in appearance. These are experiences that stayed with him for life, these experiences in childhood. That's why I really believe it's important that as we think about outreach, we really think about how we outreach to the young people today. They're going to be the ones that pick up the hobby, that become interested in astronomy, perhaps even a few of them make it a career. Kepler's formal education led him to the University of Tübingen, where he studied theology with the intent of becoming a Lutheran minister. But alongside theology, he was trained in mathematics and astronomy, where he encountered the worldview of Ptolemy and the revolutionary ideas of Nicholas Copernicus, which we've talked about. Unlike many of his contemporaries who treated heliocentrism as a mathematical convenience, Kepler believed it was physically real. He openly defended a sun-centered universe at a time where it was not popular to do that. It was a risky proposition to do that at that time, and he soon realized his future lay not in the pulpit but out in the stars. Because of his belief, he was denied ordination to the Lutheran ministry because of his beliefs. And here you can see a younger Johannes Kepler here. After graduating, Kepler became a mathematics teacher in Graz, Austria. His first major work, Mysterium Cosmographicum, in 1596, attempted to explain the spacing of planets using nested platonic solids. While the model was incorrect, the book revealed something essential about Kepler. He believed the universe was built on deep mathematical harmony, and that this harmony could be uncovered through careful reasoning and observation. Although this idea didn't hold up scientifically, it marked the beginning of a life spent seeking hidden patterns in the cosmos. Kepler's life changed, and it was also at this time that he married his first wife. She was the daughter of an innkeeper. She had connections in court. It almost didn't happen because he was so focused on the publication of Mysterium Cosmographicum. But it ended up happening. They ended up getting married. I believe they had 5 kids. 2 died in infancy. The first 2 died in infancy. They had 3 more that grew to adulthood. Pretty typical of that time with the infant mortality rate. Anyway, his life changed dramatically because of political nuances and religious. He was asked to, Protestants were asked to leave by the Holy Roman Empire and the royalty where he was, and he was allowed to stay initially, but then initially he had to leave. And his life changed dramatically when he joined up with Tycho Brahe in Prague in 1600. Brahe possessed the most accurate planetary observations ever made up to that point, especially of Mars, but lacked a theory that fit the data he had. Kepler, on the other hand, had the theory-hungry mind needed to wrestle with those stubborn numbers and to make it work. Brahe died suddenly in 1601. They thought by poisoning. Some people at that time thought Kepler may have done it. We know that after his body was exhumed, he didn't. But Kepler became the imperial mathematician, inheriting the data that would consume him for years. Mars refused to behave. Circular orbits simply didn't work, no matter how Kepler bent them. What finally emerged was something radical. Planets don't move in perfect circles at all. You got to realize back then everything had to be perfect because the universe had to be perfect. Kepler's going to challenge that. But before he could really get into this planetary motion and unravel it, the sky itself intervened. And here you can see, and you can click on this and zoom it out, but you can see that in October 1604, a brilliant new star suddenly appeared in Ophiuchus, shining brighter than Jupiter and visible in the daylight. And it was near a conjunction between Jupiter, Saturn, and I believe Mars. And for a world that believed the heavens were unchanging, this was deeply unsettling in Europe at this time. Kepler observed the object closely, returning night after night after night to track its brightness, its color, and its position. What mattered most was what didn't change. The star showed no detectable parallax, proving it lay beyond the moon. This meant the supposedly perfect celestial realm was capable of sudden and violent change. Kepler published his observations in De Stella Nova in 1606, documenting what we now call Kepler's supernova, or SN 1604. It was the last supernova observed in our Milky Way galaxy. Though he still framed this event in the religious language of his time, his conclusions were clear. The heavens were dynamic, not eternal celestial spheres. Modern astronomy identifies SN 1604 as a Type 1a supernova, the explosion of a white dwarf star after it accrued mass from a companion. Kepler couldn't have known the physics behind it, but his meticulous observations remain valuable even today. The expanding remnant is still studied across the electromagnetic spectrum over 400 years later. Here you can see Chandra's image of that. It's actually a combined image. So that new star, whoops, let's get back here. I have a little problem with my keyboard tonight. Let's make sure I get here. Since I found that, I always like to correct my errors when I see them. So that new star, reinforcing truth Kepler was already uncovering. The universe wasn't built on a philosophical perfection, but on laws that revealed themselves through observation. Between 1609 and 1619, Kepler published the work that would cement his legacy, his three laws. One, planets move in elliptical orbits while the sun, with the sun at one focus. That is abandoned centuries of circular dogma. Two, the planets sweep out equal areas at equal times, revealing their speed changes along their orbit. And three, the square of a planet's orbit period is proportional to the cube of its distance from the sun, a precise mathematical harmony linking all planetary motion. These laws didn't explain why the planets move as they do. That would come later with Newton, but they described motion with unprecedented accuracy. For the first time, the solar system behaved according to predictable mathematical rules. Kepler's curiosity reached far beyond planetary motion. He made major contributions to optics, correctly explaining how the eye forms images and improving telescope design with what we now call the Keplerian telescope. He produced the Rudolphian tables, dramatically improving planetary position predictions for astronomers and navigators alike. In a reminder that science rarely happens in isolation, Kepler also spent years defending his mother against an accusation of witchcraft. She was accused of being a witch. It was a grim reflection of the era he lived in. He eventually did, after I believe 6 years, prove her innocence after years, those 6 years of defending her, and she was found not guilty, and that was done just a year before she passed away. Johannes Kepler died on November 15, 1630, but his work permanently altered humanity's relationships with the sky. The planets followed discoverable laws that stars can explode and that the universe is alive with motion and change. For observers today, standing at the eyepiece, watching planets drift night after night, Kepler feels less like a distant historical figure and more like a kindred spirit, I think. He trusted the sky over tradition, observation over assumption, mathematics over myth. And in doing so, he helped turn the night sky from mystery into a map, into a wonder, into something to be explored and discovered. Anyway, there's our weekly tip on the astronomer of the week, Johannes Kepler. What a man. Lived through some very hard and difficult times if you actually really get into his life. Persecuted at times, actually excommunicated from the Lutheran faith because of his belief, and was able to endure a whole lot and still had a wonderful and productive life. Anyway, I hope it clears the sky where you are. They clouded up tonight for me. I'm hoping to get out tomorrow night, do some, I want to test out a new scope I got, see how it works. And anyway, we'll report back on that. Clear skies to you. We'll catch you later. Have a great one. Talk to you soon.